for life.
Hello, everyone. My name is Vladimir. I am a developer at Axelar. And in this presentation, I'm going to show you how to get started with Axelar. So a lot of you are already probably familiar with what is Axelar, but I'm just going to make a quick introduction. So Axelar is basically a interoperability network. So it's a cross-chain communication for Web3. It allows you to send cross-chain assets, so assets between different chains, and it allows you to call contracts between different chains as well. So the key takeaways about Axelar is that it's a blockchain, so it's built on top of Cosmos SDK. It uses proof of stake, so it's secure and decentralized. But that I am sure that you know already. So a quick glance of the infrastructure of the Axelar network is that Axelar network is connected to different chains through gateways. And let's say here we have a application layer. Let's say we have Ethereum, Avalanche, and Moonbeam that are all connected to Axelar. You will be able to interact with Axelar by interacting with our gateways that we have deployed on every chain. So in the case of EVM chains, it's a smart contract. So we have a smart contract deployed on Ethereum here, on Avalanche, and on Moonbeam. So in order to interact from Ethereum with Moonbeam, you'll be able to call the gateway on Ethereum, and we at Axelar will forward your call to the destination chain via relayers and validate the transactions via validators. So that's a quick overview. And in a nutshell, what Axelar can do for you, it allows you to transfer tokens between chains. So between EVM to EVM, and between Cosmos to EVM, and between Cosmos to Cosmos. You can use either the Axelar SDK, or you can directly call the gateways that we have deployed on different networks. And the other thing that you can do with Axelar is to perform basically any smart contract call between any EVM chain that we support. So you can call a contract on Avalanche that can call a contract on Moonbeam. So that functionality here is only supported on EVM chains. So regarding sending tokens, you basically can proceed in two ways. You can either use the get deposit address functionality that we provide in our SDK. And we actually have an application that uses that. It's called Satellite. It's available on testnet.satellite.money for the testnet network. And I'm just going to quickly show you. This is a testnet version that is a rebranding of the existing version at satellite.money. Let me just navigate to that here. So this is the mainnet version, and this is the testnet version. You can play around with it, see how the get deposit function works. So basically how it works is that it's an API call. You call the get deposit address function. We return you a deposit address, and you can send the tokens or the assets on the source chain to that address, and we will forward this token or asset to the destination chain. The main advantage is that you can transfer from Cosmos to EVM, which is usually not possible. And you can also transfer from exchanges because since it's an API call and you just generate a deposit address, you don't need to have a MetaMask wallet. You don't need to have a Kepler wallet. You can literally transfer from an exchange like Binance. And the other way of transferring tokens is to calling the gateway directly. So our gateway that are, again, deployed on different chains support different functions. They support, for instance, send token function. And basically, it's a function that allows the gateway to spend your ERC20 tokens and to kind of burn them and mint them on the destination chain. So prior doing that, you should approve the gateway to actually transfer your ERC20 tokens with the ERC20 approve function, and then you call the gateway send token function that allows Axelar to transfer this asset to the destination chain. So that's for sending tokens between chains and ecosystem. The other functionality is the general message passing protocol. So we call it GMP. So basically, it's a way to call any smart contract on any EVM chain that we support, and allow it to call any other smart contract on any other EVM chain that we support. So for instance, you can call a smart contract on Ethereum that will call a smart contract on Moonbeam or Avalanche. This is possible thanks to the call contract and call contract with tokens functions that are implemented on our gateways. So the main difference between call contract and call contract with tokens is that on top of passing an arbitrary message as a payload that is encoded in a ABI format, you also pass the token that you want to allow the destination address to spend for you. So that's that. A quick overview of the general message passing architecture. So this is let's take the example that is here. So we want to send from Ethereum to Avalanche. Here you will have your smart contract on Ethereum, and you want that smart contract to call your smart contract on Avalanche. So usually how it will work is that your smart contract will call the Axelar gateway that is deployed on Ethereum, and the Axelar network will detect your call and will forward it to the Axelar gateway on the destination chain. And normally you will have to actually call the Axelar gateway, so it calls your destination smart contract. But we provide a utility service for you called the fee service. We also call it a get receiver service. And it's basically a smart contract that you need to call, and you need to give it, you need to pay it the fees. So that way Axelar can actually call the destination smart contract for you. So you don't need to actually go and connect to the destination chain and call that functionality. So it's a bonus that we can provide for you. And yeah, in terms of resources to get started, I'm pretty sure that you are already aware of that, but the main resource that I can recommend is the Axelar GMP example. So it is a repository that has a lot of examples that you can run and see how the general message passing works. And the Axelar GMP example is basically using the Axelar local dev repository, which you probably have heard about already. So it's basically it's a utility library that uses Ganache to spawn EVM chains on your computer. So it's easier to test. So if you have something like Ethereum and Moonbeam and Avalanche, and you want to test your cross-chain application between those three networks, you can easily do so with the Axelar local development. You also have the Axelar SDK that I have mentioned already. It has some utility functions. One of the most important ones is the get deposit address function that allows you to get a deposit address, so you can transfer your token to that deposit address, and Axelar will forward it to the destination chain. And of course, you have the Axelar docs and the Axelar YouTube channels. I would recommend the Axelar YouTube channel because we have published already quite some content there, and a lot of content that I'm actually explaining here is already published there. So if we go here into Axelar YouTube channel, you see that you have some videos. One of them is will cover the GMP examples, and this one as well that I have made here, and that other team members of the team have made. So another interesting point is that in the Axelar documentations, you will find the resources section, and by network you will find all the information that you need to interact with the Axelar contracts. For instance, if you are deploying on testnet, you click here and you'll see all the IBC channels, and you see all the EVM contracts here that have been actually moved here. And you see that we list for all the chains that we support, all the EVM chains that we support, we list the gateway and the get receiver contract. So this gateway is a proxy contract. So when you interact with it, it's going to actually call the real gateway contract under the hood. So any questions so far? Okay, now time for a concrete example using the Axelar local GMP example. So I have a repository here, and you can find all this code, of course, on our GitHub. And I'm going to just zoom a bit so you guys can see. And so this is, I think, the most important repository that will be useful for you. This lists a lot of examples, general message passing examples, such as call contract and call contract with tokens, that are very useful to understand how to use cross-chain applications and how to build them. And we also have a so this is list kind of the CLI examples that are that are deploying the contracts, testing them, and kind of dying. And we also have a web examples with a front end that you can run. So for instance, we have examples for call contract and call contract with token. So all you need to do to test that repository is to kind of follow the README. So I will open the README here and I will show the process. The first thing when you use that library is obviously to install all the dependencies. So yarn install or npm install, depending on the package manager that you want to use. And then you need to build a contract. On my machine, it's already built. The next thing that you need to do is to spawn the Axelar local development environment. So Axelar local dev is another library that this repository is using to be able to spawn EVM chains on your computer. So it's just a utility function that allows you to work with multiple chains and not having to actually write all that logic to test your application. So all you need to do is to run that script that will spawn all the EVM chains that we support. And not only it will spawn them, it will also deploy the smart contracts on every chain that we support. So it will deploy the gas receiver, which is again a smart contract that receives the fees that you pay. So Axelar can call your function on the destination chain, and also deploys the Axelar gateway for every chain. Here is Moonbeam, then it's going to deploy on Avalanche, etc. So all that configuration can be found in info folder here in local.json, and that's going to be reset every time I restart the local development environment. And I see that there's a question: would it be possible with Axelar GMP to mint tokens from a contract deployed on a different blockchain? Yeah, definitely. It's definitely possible. Basically, everything that is possible to do on one chain, it is now possible to do in a cross-chain way. And I think we have a example here that does not mean the token; it means NFTs. So it's NFT linker. But basically, once you check a couple of examples here, you will be able to understand, I think, how to implement something that you want to implement, Lamont. No worries. So here again, I have the local development installed and running, and now I can test our examples. First, we need to deploy those smart contracts and then run them. So again, all you need to do is to follow the README. We have two scripts that you might use: the node scripts, the deploy script and the test script, right? And those scripts are here: deploy and test. So it accepts arguments. So I'm going to open a terminal here, and I'm going to run first the example that we want to run. Let's say call contract, right? So it's a GMP example where you want to call a contract from a source chain, let's say Ethereum, to a destination chain, let's say Moonbeam. So we are going to deploy the example. So node scripts deploy, and this has to be done every time that this environment is restarted, right? Because kind of locally running in the memory. So if I kill it, I'll need to, and I run deploy, I'll need to restart it again to be able to have the contract deployed there. Here we go, and I'm going to deploy, and here you can indicate whether you want to deploy locally, so on your computer using the local development environment, or in testnet. In this example, we're not going to show testnet, but basically, if you choose testnet, it's going to fetch this testnet configuration here, and based on the addresses and the RPCs, is going to deploy on that address. Obviously, you need to have an address that has enough cryptocurrency to be able to perform all those transactions on all the chain that you support. But here, everything is kind of free because we are running it on our computer. So here we are going to select local, and it's an error. Let me see what error it is. Did I write it incorrectly? Oh yeah, I didn't specify which examples I actually want to deploy. So the example is call contract, and it's in the folder example. So example call contract, and it has been deployed right now on that local development environment, and you see those addresses are here, and it should be updated in the local.json configuration, and you see that executable sample is there, has been updated. So it kind of logs where it has been deployed. And the next thing, once it's deployed, you need to execute the contract, right? Call the function on the source chain. So it calls the function on the destination chain. And for that, you can execute the next script. So it's like, instead of deploy, it's going to be test. And it's going to, again, it uses the same format. You give the example that you want to run and the environment where you want to run it. So we see that is basically kind of a simple setter contract. The transfer, I think, in the example, let's check it out, actually. It's from Avalanche to Phantom. So we pass a value, we set a value from Avalanche to Phantom. The initial value at Phantom is empty. And after the cross-chain call has been executed, the value is set to the value that has been encoded. And I believe it will be somewhere there here. Hello, destination name, from, source name, and the date. So in the same way that we have run the call contract example, you can run all the examples here. You just replace the folder names, right? The next thing I'm going to show you is how to use the interactive examples, because I think it's a bit more speaking than those ones. So I'm going to kill the terminal here, kill the local development environment, and go into the examples web folder. So examples web. And the examples web, I have call contract with tokens. Let's try call contract. So it's the same example that we have in the CLI examples, except that there will be React UI and to be a specific Next.js UI that will connect to the local environment. And I think it's the closest thing that you can get to an example that can tell you how to use cross-chain applications. So here I also need to navigate into that folder, so call contract. And there is a README as well that all you need to do is to follow. Here, you first, of course, need to install the dependencies. If you haven't, then you need to copy the environment variable. Here, it just creates a random mnemonic and it puts it in the env here, so the application can use it. Then you run the local development environment. So it's in the scripts here, and it's called start local dev. So under the hood, it runs the Axelar local dev, which is similar to what we do in the global examples. It's imported a bit differently. So here I just specify that I want to use Ethereum and Avalanche, and I want the configuration to be exported in config chains.json, right? And I want to fund an account with USDC that we automatically deploy as well as part of a ERC20 token that you can test, and we fund that address, which will be coming actually from that mnemonic. So if we run that development environment here, it's going to be pretty similar to what we had just before, except that it's going to deploy on two chains, Ethereum and Avalanche, and you see that it deployed the wrapped USDC, and the Axelar gateway and the GET receiver contracts. Then we need to build those contracts since it's Solidity code here. And we need to generate the artifacts. So let's go ahead and build them. And we can deploy them. It's going to deploy automatically on that local development environment. And while I have this local development environment running, I will start the UI here, and that should open me a user interface where I can test that call contract with token. It's a pretty simple UI. So I have a card representing the Ethereum network, and I have a card representing the Avalanche network. So in this example, I'm going to use call contract function. So calling a contract on Ethereum that will, through Axelar, call contract on Avalanche and pass that arbitrary message and set it to that contract. So let's say hello from Ethereum. We send that transaction. The actual local development environment actually tries to reproduce what Axelar is doing. So it is picking up the transaction, it is relaying it on the destination chain, and it is calling that smart contract on the destination chain. And if we refresh that smart contract, we get the value that came from Ethereum. So that's basically a very simple hello world cross-chain application. Let's maybe go through the smart contract to quickly show how it's done there. And where's the repository? Here's it. And if now that we have kind of an idea of an example that you have seen visually, let's go in the contracts folder and see what happened there. So we have a message sender contract. So that's the contract on Ethereum that's going to send to another contract, message receiver. We just call them differently, so it's very easy to understand that we actually send a message from a sender to a receiver. This contract lives on Ethereum. This one lives on Avalanche. So the message sender should be aware of the gas receiver. Otherwise, you will have to manually call that smart contract on Moonbeam. So if you pay the fees to the gas receiver prior to executing the transaction, Axelar will actually relay the transaction and call the function on the destination contract. So this smart contract is also needs to be aware of the Axelar gateway because it needs to call it. Remember, the function that we are calling here is call contract. So it's a function available on the gateway, and you see it here. And basically, this is an arbitrary function on the source chain that we call through our UI. We specify the destination chain, the destination address, and the payload. It can be any payload because we are encoding it in an ABI format. So everything that can be encoded in the ABI format can be sent through GMP, through general message passing. Basically, it can be an array of strings, it can be a string, it can be an array of addresses, it can be pretty much everything that the ABI encoding supports. So we encode that in a payload, and then the function checks if there are like some values that has been sent along with the call. So for instance, some Ether to pay for the transaction. And if there is, we will pay the gas receiver with native gas. The gas receiver has other functions that you can use. You can pay with tokens, for instance. You can pay with other means. You can check the functions available on the gas receiver contract. But here we are using the gas pretty much. So very important. If you don't have that in your code, you will have to manually call the function you want to execute on the destination chain. If you have that call and if the fees provided are enough, Axelar will call that function for you. So, and then after that, you call the gateway call contract function. You specify the destination chain. So it's going to be Avalanche. The destination address is going to be the contract that you want to call on Avalanche, and the payload that you have encoded here with ABI encoded. So that's for the sender contract. It just needs to be aware of the gateway. It doesn't have to be aware of the guest receiver, but it's better that way. You don't have to worry about executing the transaction on the destination chain. So for the contract that will receive the call from Axelar, there's a bit of implementation that you need to do. You need to basically inherit that contract from Axelar executable interface. So this means that if you want that contract to be executed by Axelar, you need to provide a special function, and you see it here, _execute. There's also a function called _execute with token if you transfer the tokens from the source chain to a destination chain. So basically, this is a special function that you should reserve for Axelar, and the contract needs to extend that interface. That way, Axelar gateway can actually call that function. So technically, once you pay the fees and once you call the gateway on the source chain, and you provide on which chain you want to call, with which payload, and at which address, Axelar will forward your call and will call the contract at that address here on the destination chain. And it will call that specific execute function. It will provide some information about the call, such as from which chain the call has been called, from which address, and the payload that is encoded in a ABI format, so that you need to decode. And since you have created the source contract, you would know what kind of payload is there. So you can, you know that I'm passing a string here, so it should be a string. So you decode it and you cast it to a string, and then pretty much you can do whatever you want. It's really up to your imagination. So you can mint a token, you can burn a token on that chain and mint a token on this chain, whether it is a ERC20 or ERC71 or anything else. Basically, the imagination is your limit. And what it does here is that it takes that value that we pass from Ethereum, and it sets the source chain variable here in the store to that value that is passed from Ethereum. So that's roughly how it's done. And we are going to show a quick example with call contract with token, because that's also a very important GMP functionality that you might use. Let me just stop this environment and go back to the other example in call contract with token. It also has its own UI. I'm going to kill that. And let's navigate here in call contract with token. So it's very similar in terms of structure to the call contract, except that the smart contract is a bit different. It also has a receiver and a sender. So in this example, it's a bit more complex. So again, the sender needs to implement the gateway. It needs to implement the guest receiver. We pass the destination chain, destination address, and here is kind of a arbitrary payload that is going to be encoded. Let me actually hide that a bit. And on top of that, we pass the symbol of the token you want to send and the amount of the token. So this call contract, and once the call is executed, we call the call contract with token. So just a bit of a, I would say, introduction to call contract with token. Why it exists is because a lot of times you just want to call a function from a chain A to chain B, but sometimes you know that you're going to transfer tokens along the way, and this is a perfect example for that. We are transferring some tokens from chain A to chain B, and we also provide some custom logic. For instance, not only we transfer tokens on that address, but we also want to instruct in one call to that address to do something with it. In this case, it's kind of an airdrop application, so it will take the addresses that we provide here, and it will split equally the amount of tokens that we send here, and the token amount is specified by the symbol there. So if we go through that code to clear out everything, first of all, we do a call to the gateway, and all the gateways that we deploy on Axelar network map the addresses of ERC20 contracts. So all the gateways on Ethereum know which ERC20 contract we support. In the same way, on an Avalanche or on Moonbeam, they would have the same information. So every gateway can get the address of the ERC20 that exists on its local chain through that function, gateway token addresses, and you specify the symbol, and it's going to return the token address of that ERC20, right? Then you also need to import the interface of ERC20. You call the transfer from function, so you allow this contract to transfer your ERC tokens, and you approve the gateway to transfer them as well, because the gateway will actually need to burn them, and on the source chain at least, and the gateway on the destination chain will mint them, right? So we then encode the array of addresses in the ABI format, so we can pass it in a universal way. We pay for the fees, so we don't need to call the destination contract manually, and then we call the call contract with token. So it's very similar to the call contract, except that there's this overhead of transferring the token that you need to be aware of. And on the destination chain, again, the contract that receives a call from Axelar needs to implement the Axelar executable interface. And here you have the other function, execute with token. So knowing that it's a call contract with token, Axelar will call that specific function, and it will provide the payload that you have passed in the source contract. And it will provide the information that you basically have passed here in the gateway call. And here we decode. Again, we know what kind of data we will be passing because you program those smart contracts. You know that you are expecting an array of addresses, so you decode it with the ABI and you cast it to an array of addresses. Then you get the address of the token on the destination chain, because they are not necessarily the same. The Axelar USDC on Avalanche will not necessarily be at the same address as the Axelar USDC on Moonbeam. And we need to have those contracts deployed on all the chains so we can do the transfers via the burn and mint mechanism. So we get that address, and then there's a simple function, basically an airdrop, that divides the recipients, that divides the amount that we want to send based on the number of recipients. And that's pretty much it. Obviously, you can customize your logic. You can add events like here, so your UI can cache that data and can update. So now that we have a bit of a introduction to call contract with token, let's actually run the UI and see it in action. So I'm going to open the terminal. I'm going to just follow the README again. Where is it? Here it is. First of all, copy the example env into the env, then install. I think it's already installed, but I'll do it regardless. I need to run the local development environment in parallel. So once it will be finished, I can do that. Now open another terminal. I need to build the contracts. And I need to deploy the contracts on that environment. And once it's deployed, I can start the UI. Here we go. Actually, I can just refresh that. So the UI is very similar to the previous one, except that we have Avalanche and we transfer to Moonbeam, and we have a sender account that has a lot of USDC. And you can provide, it's basically an airdrop, right? You can provide how much tokens you want to send. So it's going to be, I don't know, 1,000 USDC. And we want to send them to some addresses. I can either put the addresses here, but I'm just going to generate a couple of addresses there. Let's say 5 addresses, right? So I want to divide those 1000 USDC among those 5 addresses on the destination chain. I'm going to send that, execute the transaction. And in this case, the UI will automatically update based on the event that has been generated on the destination chain in the smart contract. So we see that the amount that we send has been equally divided between the participants, between the recipients, and some fee has been taken out of that amount. Okay, that's pretty much everything I wanted to cover. We covered if we go back, we covered the call contract with tokens. Those will be the main functionalities that you want to use. Again, those functionalities are general message passing, GMP, only available on EVM chains. They are not available on Cosmos chains at that time, but could be available in the future. If you want to just transfer the tokens, you can use the send token function on the gateway contract, or the get deposit address function in the SDK. And if you want to do something more complex, such as calling a arbitrary function from one chain to another chain in the EVM ecosystem, you can use the call contract and call contract with tokens. And again, all the useful resources are available here. Yeah, and I think we will start the question time if you have any. Okay, it seems with that we have no questions. I hope it was useful. I hope this presentation was useful, and that it helped you to understand how to use the Axelar ecosystem to build cross-chain applications. And here we go. Thank you, guys.